All right, guys. Dilations is what we're studying in section 4.5. So if you go to this foldable, we'll go over it. This foldable is the only notes we have. We don't have like extra notes like we do for some of these sections. And what we cover here will be the last foldables for section, or for chapter 4, I'm sorry. We do have one more section. We have section 4.6, but we don't have any foldables that go into our interactive student notebook for that. We're just going to do like a page front and back worth of notes. But anyways, dilations, so we're going to do this foldable here. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C. Now, when I say enlarged, I mean it gets bigger. And when I say reduced, that means it gets smaller. Okay. C is called the center of dilation. And when I talk about this, you're going to hear me talk about K a lot. K is referred to as the scale factor. Now, why that is, I have no idea. But generally speaking, anytime you see K, it's talking about a scale factor. And the scale factor is simply the ratio of the image over the pre-image. And it's usually written as a fraction, a reduced fraction when you put in your homework. I don't think Big Ideas will accept it if it's not in reduced form. All right, so something else I want to note here is that we have an enlargement. Remember, an enlargement is when we get bigger. And that's when the absolute value of our scale factor is bigger than 1. And then we have a reduction. And remember, a reduction is when we get smaller. That's when the absolute value of our scale factor is less than 1. All right, so let's look at a few examples. So if you open up your interactive student notebook, this is example 1, and it has 2 parts. Okay, so we want to find the scale factor of the dilation. So we want to find the scale factor. So we're going to put K equals. And remember the formula to find the scale factor, it's just image over pre-image. All right, so then tell whether it's a dilation is a reduction or an enlargement. So reduction is we get smaller, and enlargement we get bigger. All right, so if I look at this, the first thing I want to do is I want to identify the image and the pre-image. Okay, so I have to look at what the names are. So this is my P, this is my P prime. Okay, now notice P prime comes after P. So that means my P has to be my pre-image, and then my P prime has to be my image. Okay, so as you can see, we're going from smaller to bigger, so I can immediately say, well, this is an enlargement. All right, now I want to find my scale factor. So my scale factor is image over pre-image. Okay, so the image is my P prime, so the length of this whole P prime here is 12. Okay, and then over my pre-image, so my pre-image is from here to here, which is 8, so 12 over 8. If I reduce this, which Big Ideas will want you to do, I get my scale factor is 3/2. All right, now using part A as an example, I want you to do part B on your own. So find the scale factor and determine if it's an enlargement or reduction. Now, the first thing you need to do before you do that is you need to identify your image and your pre-image. So make sure you look at your P and your P prime and determine your image and your pre-image first. So go ahead and do this one on your own. All right, so when we looked at this part B, I noticed my P prime is here and my P is here, which means this is my pre-image. I start with my P, I start with my pre-image, and I end up with my P prime, which is my image. So we are getting smaller, so that tells me it is a reduction. Okay, then I go to my scale factor. Now remember, my scale factor is image over pre-image. Well, if this is my image, I want to know the distance right here, which is 18, over my pre-image. Now I want to know the distance here, which is 30. So 18 over 30 reduces to 3/5. All right, so let's look at example 2 now. It says in dilations, CP prime is equal to 3, and CP is equal to 12. We want to find the scale factor and then tell whether it's a reduction or an enlargement. All right, so once again, the first thing we need to do is we need to look at these letters and we decide which one the image is and which one the pre-image is. Okay, well, we know this one has to be our image and this one has to be our pre-image because this is CP prime. That means we've done something to it. Just CP, we haven't done anything to it yet, so it's our starting point, so we start with our pre-image. Okay, now if this is our pre-image, this is what we start with, and this is what we get to, we can easily see 12 to 3 that we're getting smaller, so this would be a reduction. Okay, and remember my scale factor is image over pre-image, which is 3 over 12, which reduces to 1/4. All right, so let's go ahead on this before we even start. Let's go ahead and rewrite points A, points B, and point C over here. So A is 2, 1, B is 4, 1, and C is 4, -1. And I just got that straight from here. Okay, now I'm going to go ahead and graph it. So go ahead and graph it. All right, so after you graphed it, you should have got something like this. All right, so we're going to dilate this by a scale factor of 2. Okay, so we're going to get A prime, B prime, and C prime. And we're going to find the coordinates of those, then we're going to plot them. All right, so when it says to dilate by a scale factor of 2, what we're going to do is we're going to multiply each original, oh my gosh, I can't spell, each original coordinate by 2. Okay, so that means if I take 2, 1, that's my original coordinate. If I multiply each number by 2, so 2 times 2 is 4, 1 times 2 is 2. Okay, 4 times 2 is 8, 1 times 2 is 2, and 4 times 2 is 8, 2 times -1 is -2. Okay, then I'm going to plot those 3 points. So go ahead and plot those points now. All right, now when you plot it, this is what it looks like. So what that means is triangle ABC compared to triangle A prime, B prime, C prime. Triangle A prime, B prime, C prime is 2 times the dimensions as ABC. And also something that's kind of cool is if you were to connect like the origin with A prime, it would pass through A. If you'd connect the origin with B prime, it would pass through B. And if you connected it with C prime, it would pass through C. It's kind of a cool thing. All right, let's go ahead and look at example 4. Now, before we start, just to save on time, I want you to write the coordinates here, going downwards. So I just pulled those straight from here, and then also graph those coordinates. So go ahead and do that real quick. All right, so hopefully you've written these out and you've plotted this like you should have. Now we're going to dilate this by a scale factor of 1/3. Okay, so that means we're going to multiply each of the original coordinates by 1/3. Okay, now think about it. When we multiply something by 1/3, it's the same as dividing it by 3. Okay, so that might help you a little bit. So K prime, L prime, M prime, and N prime. Okay, now 1/3 times -3 would be -1, or -3 divided by 3, same thing. Multiplying by a third is the same as dividing by 3. 6 times a third is 2. 0 times a third is still 0. 6 times a third is 2. 3 times a third is 1. 3 times a third is 1. -3 times a third is -1. -3 times a third is -1. So these are my new coordinates. So go ahead and plot these coordinates here. All right, so what you get should look like this. All right, guys, so there's 2 more things that should go into our interactive student notebook before we kind of cease with chapter 4. And it's this, the dilations definition, and also just this rule page. This should be very, very, very handy because this is just a compilation of all the rules into one, okay? But the dilation definition, it's just a dilation is a transformation that produces an image that is the same shape as the original. It stretches or it shrinks the original figure. So I'm going to put here, it makes things bigger or smaller. Okay. A dilation is not an isometry or not a rigid motion. Okay, so we do not produce congruent figures. What we call them are similar figures, and we'll really go over that in next chapter.